Hi, I'm Lauren Walker. I'm a software developer for the Arctic Data Center, and today I will be talking about the project Permafrost Discovery Gateway and how we are doing these pan-Arctic high-resolution visualizations for the gateway. So I'll go ahead and explain this by using an example data set, the ice wedge polygons. And so this is just one feature that the gateway is focusing on. And ice wedge polygons are basically, as the water in the permafrost freezes and thaws many times over years and years, the soil cracks and buckles and it creates these ice wedge polygons. And in this photo, you can see that they are pretty visible from the air. So just like there's big data, the Permafrost Discovery Gateway is analyzing big imagery. These are coming from global satellites that take photos of these ice wedge polygons. And then we use machine learning to detect them at a super fine sub-meter resolution. So we start with one of these satellite images and we detect the visible troughs and the raised centers via machine learning approaches such as convolutional neural networks, CNNs. And this algorithm is trained with polygon data, and then it can automatically run and detect them on its own. So we will apply this model over and over again across the entire Arctic, and we end up with a global Arctic data set of ice wedge polygons. So because this is such a huge data set, it will be hundreds of terabytes of files. And so we're going to take all of those files and index them in a spatial database so that we can easily search for files that contain polygons within a specific region. So in order to make these polygons easily viewable in a map in your web browser, we need to process them into tiles. So what we're doing is creating complex 3D tiles in a mapping platform called Cesium. It's an open interactive mapping platform that you use in your browser. And there's currently no open source solution for creating these 3D tiles in Cesium. So we're currently expanding this Python library called Py3D tiles to support the 3D tiles format. And all of the solutions in the market right now that create the Cesium 3D tiles are closed source and fee-based. So we're hoping that this will be a big contribution to the open source community. So the resulting web user interface lets researchers zoom into areas of interest and see the ice wedge polygon vectors overlaid with other data layers of interest. They can control visibility and opacity of the layers and can create publication-ready maps for their research projects. Because of the previous tiling step that I just talked about, the application will support zooming all the way into sub-meter scales, even though these data sets are global in coverage. So as the gateway matures, we will continue adding additional data layers from the research community. Users can explore the features of these data layers, overlay them, and eventually can import their own data into the system. The resulting web UI lets people zoom into whatever specific area they want to look at. You'll be able to click on one of the individual ice wedge polygons and view attributes about that polygon. This is a mock-up of the user interface. We currently have the gateway up online right now. The link will be in the poster itself, but you can go online and play around with this demo yourself and look at a sample of this ice wedge polygon data set. Right now we just have a very small amount of the polygons uploaded because we're still working on that tiling infrastructure, but soon you will be able to look at the whole north slope of Alaska, and then currently ice wedge polygons in an area of Russia are being created as well. So here's a more zoomed in look. Again, you'll be able to look at individual polygons, which is takes a lot of extensive work considering that this is analyzed across the global Arctic. This is biophysical permafrost zones data set layer. So this is just an example of a different layer that will be displayed in the gateway, and again clicking on one of the features and viewing just a little bit more information about it. So we're hoping that the gateway will provide powerful visualization and exploration features that support scientific understanding of Arctic systems. And the system is fully open. We encourage folks to use it, contribute to it, and join us in building it. I'd like to acknowledge all of my co-authors and collaborators on the gateway, the whole PDG team, everyone who's contributing software and data. Thank you.